In this lesson, we will be solving one-step inequalities. So first, let's talk about what an inequality is again. We have had one-step equations. For example, when we had 5x is equal to 20. When you have an equal sign, you're saying that there is one solution. So to solve this, we would find the variable. It is being multiplied by 5. So we do the opposite of that, which is divide by 5 on both sides of the equation, and x would be equal to 4. This means that the only solution is 4. And if you were to graph it on a number line, you would have a dot just on 4 showing that that's the only answer that there can be. When it's inequalities, we do not use an equal sign. We use a greater than or less than or greater than or equal to or less than or equal to signs. That means that the solution is not just one answer, but it's a range of answers, a range of numbers. And so we're going to be looking on how to solve those. So it works just like a one-step equation, but you have to interpret the answer differently. First of all, you're going to locate the variable. Once you locate the variable, this one is on the left side. You want to get the variable by itself on the left side. It is being added to 9, so you have to move this to the other side of the equation. We do that using our inverse or our opposite operations. Since it's a positive 9, we're going to do a negative 9 on both sides of the equation. And 15 minus 9 is 6. So the solution is x is less than or equal to 6. So what does that mean? It means that any number less than 6 is the solution, or it could be 6. It's also equal to 6. That means not just every whole number, but every fraction, every decimal. It could be 3 1/4, it could be 4 55 hundredths. Any of these numbers that are less than 6 could be one of the solutions. That's how we interpret it. That's what it means. So when we graph it, we go to 6 on a number line. Since it could also be equal to, we do the colored in dot to show that it could also be equal to 6. And then our arrow goes to the left, showing that it's all of these numbers that are less than. Now in our last video, we talked about how if the variable is on the left side of the equation, then the sign actually shows you the direction that the arrow is going to go. Here we have d minus 3 is greater than negative 6. First we look for the variable. It's on the left side, so we want to move what's on the same side with it over to the other side. Since it's a negative 3, we're going to do a positive 3 on both sides of the equation. Here we have to remember our rule about same signs adding, keep, different signs subtract. We have a negative 6 and a positive 3. So we're actually going to subtract them since they are different signs, and keep the sign of the one with the greatest absolute value. That is negative 3. So d is greater than negative 3. It's not equal to negative 3, but it's any number greater than negative 3. So we do our open dot on negative 3 because it's not equal to it. And then we have an arrow going to the right, just like the sign shows right here, and that works if the variable is on the left side. If it's not on the left side, it's going to go the opposite direction. We're going to do the same thing with fractions and decimals. This time, for the first time, we have the variable on the right side of the equation. We want to get it by itself, so we have to move the 3 to the other side. It is a negative 3, so we're going to do a positive 3 on both sides of the equation. Now, adding 2 1/2 and 3 is pretty easy because we just go 2 plus 3 is 5, and then we have a half more. So we have it written like this, but see how the variable is on the right side of the equation? So when we read it, we actually have to start and read right to left, or you can think about what it would be like if you flipped it. So this says t, and then since this narrow part of the sign is towards the t, this is the less than, so t is less than or equal to 5 1/2. If you like it, you can flip the answer. I can put the t on the left side instead of the right side. Then I have to flip the sign. Notice with both of these that the narrow part of the sign is toward the t, And if you have the variable on the left side, this side, the sign will show you which direction the arrow goes. So if the variable is on the right side, this is going to be the opposite that the arrow goes. So this says t is less than or equal to -5, can also be written like this. So we're going to put a colored in dot at 5.5. So I just estimate halfway between 5 and 6. So somewhere around in here is 5.5. It's less than or equal to, so I color in the dot and draw an arrow to the left. Same with decimals. Here again we have the variable on the right side of the equation. We have a -4/10, so we're going to do a +4/10 on both sides of the equation. Now on the right side we have a 7/10 plus 4/10, so we add 7 and 4 and get 1 and 1/10. It's greater than or equal to n. Notice again that the variable is on the right side instead of the left side, so we could read it this way. N is less than, because the less than part of the symbol is next to the n, or equal to 1 and 1/10. Since the variable is on the right side, the arrow is going to go in the opposite direction, or you could flip it so that the variable is on the left, or you can just know that if it's on the right side, the arrow is going to go in the opposite direction. 1 and 1/10, we have to estimate where that is here. We know it's a little bit more than 1. We fill it in with a colored dot because it's equal to, and the arrow goes to the left because it says less than, and less than always goes to the left. Less is left. Let's look at this example. The memory in Tina's camera phone allows her to take up to 20 pictures. So she cannot take 21, she cannot take 22, but she could take 2, she could take 7, any number up to 20 pictures. She has already taken 16 pictures. Write, solve, and graph an inequality to show how many more pictures she could take. Well, she has 16, and there's a certain number more that she can take, but when you add what she's already taken to what she can also take now, it still has to be less than or equal to 20 because that's all that her phone holds. So our equation would be 16 plus this unknown number, the number of pictures that she can still take. All of those together have to be less than or equal to 20. We solve it the same way. The variable's on the left, so we're going to do a -16 on both sides of the equation. So we have 20 minus 16, which is 4. Our variable's on the left, so we can just read it, and it shows us the direction of the arrow. But let's think here for a minute. On your phone, can you take a half of a picture? Can you take 3/4 of a picture? You have to think about these because sometimes we actually do not draw an arrow. When you draw an arrow, you're showing that it's every integer and every fraction and decimal in between the integers. In this particular scenario, she could take up to 4 pictures. Well, she could take 0 pictures. She could take 1 picture, 2 pictures, 3 pictures, or 4 pictures, but after that she'd be over her 20 picture limit. But instead of doing an arrow, we're actually going to do this with points. Now she can't take -1 pictures. It's impossible to take negative pictures. So when you think about it, she can only take 0, 1, 2, 3, or 4 pictures, and we indicate that with points instead of a line because you do not want to show that fractions and decimals would be part of the solution. Josh can bench press 220 pounds. He wants to bench press at least 250 pounds. Write and solve an inequality to determine how many more pounds Josh must lift to reach his goal. Well, let's think about it. He's at 220. He wants to get to 250. So when we write the equation, here's what he has at right now. He's going to add a certain amount, and he wants that to be at least. So this is the minimum of what he wants. So this number is going to be greater than or equal to 250 because he wants something more than that. So here we isolate the variable. The variable's on the left side. So we're going to subtract 220 on both sides of the equation. P is going to be greater than or equal to 30. So he needs to add at least 30 pounds. Now, when you add weight, there we go, it could be anything over 30. So we put a circle dot at 30 and our line going to the right to show he could add 30 pounds, he could add 35 pounds. If possible, he could add 35.5 pounds. I'm not sure that weights work that way, but he could add a shoe to the weight or something to add a half a pound, so that's possible. Now we have to, this is the one rule in one-step equations that you have to be careful of. When multiplying or dividing by a negative number, you have to flip the sign. So let's look at this example. Here we have negative 8x is greater than 72. The variable is on the left side. It is being multiplied by negative 8. The opposite of multiplying is dividing. What are we dividing by? We are dividing by a negative number because we are dividing by a negative 8. If you are multiplying or dividing by a negative number, the inequality sign is going to flip. So negative 8 divided by negative 8 is 1, so that just leaves us x. We flip the sign, so instead of a greater than sign, it becomes a less than sign. And 72 divided by negative 8 is negative 9. So the solution is any number less than negative 9. And the variables on the left, it shows us the direction that the arrow goes. So we put a circle dot on negative 9 and it goes to the left. We flipped the sign. This is a very important rule. Now look at this example. Here is the variable. It's being multiplied by 3. So we have to divide both sides by 3. Now, what are we dividing by? We're dividing by a positive 3, not a negative number. So in this scenario, we do not flip the sign because this is what we're dividing by, and it's positive. It doesn't matter that there's another number in this equation that is negative. It's what number are you multiplying or dividing by? This is positive. Do not flip the sign. 3 divided by 3 is 1, so that leaves us our 1x, so the 1 can be invisible, is greater than negative 9. We did not flip the sign because we divided by a positive 3. So we are going to put a circle dot on negative 9, and we are going to draw the arrow to the right because it's greater than. Here we have the variable on the right side. X is being divided by negative 2. The opposite of dividing is multiplying. So we're going to multiply both sides by a negative 2. We're multiplying by a negative number. Remember the rule. When multiplying or dividing by a negative number, flip the sign. Since we're multiplying by a negative number, we're going to flip the sign to a less than sign. Negative 2 divided by negative 2 is 1, so we have x left on the right side. And negative 2 times negative 3 is a positive 6. So this reads x is greater than or equal to 6. So we go and put a filled-in dot or a color dot on 6. Let me erase this so it doesn't look so muddy. This shows it multiplying by negative 3. So colored in dot at 6, and it goes in the opposite direction because the variable is on the right side. So this reads x is greater than or equal to 6. Ryan has a $16 gift card for a health store where a smoothie costs $2.50 with the tax already included. What are the possible numbers of smoothies that he can buy? Now, he can't buy half of a smoothie, a 3/4 of a smoothie. He can only buy whole numbers. He can only buy 1 smoothie, 2 smoothies. So let's think about what equation this would be. He has $16, so he can't go over $16. That's the most it can be. And it's $2.50 per smoothie. So when we write this, we would write $2.50 times the number of smoothies. That has to be less than or equal to $16. $16 is the most he can spend. That's why the wide part of the sign is toward the $16. N is being multiplied by 250, so we divide both sides by 250. And $16 divided by 250 is 6. So when you graph this, we're going to again use just points. We're not going to use a line because he can't buy 3/4 of a smoothie or 1 2/3 or 1/3 of a smoothie. He can either buy 0, 1, 2, 3, 4, 5, or 6 smoothies with his gift card. And that is solving one-step inequalities.